Now we're taking a look at 12.4b, which is all about the volume of cylinders. So we have two types of volumes of cylinders, the formula, but they basically mean the same thing. Remember how the volume of our prism was the area of the base times the height? Well, that's the same for the cylinder, much like the surface areas are pretty much the same, but in a cylinder, the base is always going to be a circle. So if we imagine a cylinder, like a can of soup, or like a can of soda would be a cylinder, we would have the volume is the area of the base times the height, but the area of the base is always going to be a circle, so it's going to be pi r squared times h. So same exact idea, just with always being a circular base. So we have the area of our base here, and then we have the height of our cylinder is still the distance between our bases, so the distance between our circles. And there we have it. So we can find the volume using these two dimensions. Or I guess it would be 3 dimensions with the area of the base being 2 dimensions. Alright, so we're going to find the volume of some cylinders. So our first one here, we have an oil drum, and we want to find the volume of this cylinder. Alright, if you want to pause the video and try it out for yourself, please do so. But we have, since this is a cylinder, we have our volume is going to be pi r squared times h. So all we need is r and h. Alright, so taking a look at our cylinder, we have our base is the circle. So we have the diameter is 4 feet, so that means that the radius is going to be 2 feet to help us find our area. Next, we have the height of our cylinder. It's just the distance that the circular bases are apart. So we have that's 7 feet. Alright, now all we got to do is plug it into our equation. So we have our volume is pi times the radius of 2 squared times the height, which is 7. Alright, so we have 2 squared is 4, and then we have 4 times 7 is going to give us 28, then that's times pi. So we can either leave it as a pi of 28 pi feet cubed, or we can approximate, which is going to be about 87.96 feet cubed for this volume. All right, so let's try another one. So if you didn't pause the first one, make sure to pause this one. I do want you to try this one on your own. All right, so we still have a cylinder, so it's going to be the volume is the area of the base times the height, or pi r squared times the height. So we just need our radius and we need our height. So we're given our diameter is 20 yards, so our radius is going to be 10 yards, because it's going to be half of 20 for our radius. Alright, and then we have our height is 26 yards. So all we got to do is plug it in. So we have pi times our radius of 10 squared times our height of 26. Alright, 10 squared is 100. And so we'll multiply that by 26 and pi. So 100 times 26 is going to give us 2,600 pi, which we can leave it like that for yards cubed, or we can approximate, so we can multiply them together. So 2,600 600 times pi is going to give us 8,168.14 yards cubed. So again, either one of these is an acceptable answer. Just if you leave it in pi, make sure to add the pi onto the end. All right, so lastly, we have a word problem. All right, so we have a large cylindrical tank that collects rainwater. So we want to find the volume of concrete that's needed to make the cylindrical tank. And we have that it is 4 feet in diameter and 3 feet tall, and it has 3-inch thick walls. So if we think about a cylindrical container, so we have our cylinder on the outside, and we're given some dimensions. So we're given that it is 4 feet in diameter. So across the top, we're given that we have a diameter of 4 feet. All right, we have that it is 3 feet tall. So again, my measurements aren't particularly correct because 3 feet is obviously smaller than 4 feet, and we have that that's a little bit longer, but that's what we get when we sketch graphs. And then we have it has 3-inch thick walls. So that means in the container, it's not like the wall is paper thin, but instead we have that it has 3-inch thick walls on either side. So imagine that we kind of have this smaller cylinder on the inside of our container that illustrates those 3-inch thick walls. All right, so like we would have 3 inches on this side and 3 inches on this side for our wall all the way around. All right, so we're going to have to do some calculations here. So we want to basically find the volume of the concrete needed. So we're not finding the volume of the inside container, but we're finding the volume of the container itself. So like the whole thing minus the inside that we've drawn here. All right, so I'm actually going to make one of these a different color so we can distinguish. We're going to make the big one, we're going to make that one blue. Just so that we can color code our volumes over here and you know which one we're talking about. So we're going to look at the volume of the whole, which we're going to do as W. And then we're going to do that versus the volume of the inside. Because in order to find the volume of the concrete, we have to subtract these volumes. All right, because we're basically taking the whole thing and we're subtracting out the inside. All right, so we're given some dimensions in feet and some dimensions in inches. So we're going to change them to inches. We're going to change all of our calculations into inches. So for example, 3 feet is going to give us 36 inches. And 4 feet is going to give us 48 inches. So now we're in the exact same measurements for all of them. We're all in inches. All right. So we have that the diameter is 48 inches. So, again, this is the diameter that we're told. So that means that the radius of the whole thing is going to be 24 because it's going to be half of that volume, or half of that length, the radius. So if we want to find the volume of the whole thing, including the space in the middle, we have that that's going to be our 24. So we have volume is the area of the base times the height, which is pi r squared. So we have pi times the radius of 24 squared, and then that's times the height, which we have is 36 inches in there. All right, so if we multiply that all out, 24 squared, and then that times 36, that's going to give us, oh, I should have done that in blue. Hold on, we're going to rewrite that in blue, just so we know which container we're talking about. So we have pi r squared times 36 inches for our height, and that is going to give us 20,736 pi. So we're going to keep it as pi for now, because we don't want to approximate until the very end. So again, this the blue one had a radius of 24 inches and had a height of 36 inches. All right, now we're going to look at the volume on the inside. So we're still finding the radius and the height, and we want to, excuse me, and we want to find our volume here. So one thing I didn't account for is with our 3-inch thick walls, we actually have that on the bottom as well. So we have a 3 inches down here between the bottom of our container and the bottom of the gap on the inside. So 3 inches all around. All right, and we're going to find our volume here. So we need our radius. So for our radius, we are, if we take a look at our diameter, we have that our diameter was, of the big one, was 48 inches at the top here. And we're basically shaving off 3 inches and 3 inches on either side at the top here. So we're shaving off 6 inches, which gives us 42 inches for the diameter of our inside volume. And if we divide that by 2, that's going to give us 21 for our radius. So we have 21 inches is our radius on our inside container. Next, we want to find our height. So with our height, we're taking off that 3 inches on the bottom of our container. Since it's collecting rainwater, we don't have that 3 inches at the top because it would be collecting from, actually no, we would have that 3 inches at the top. So if it's 3 inches all around, we're going to take that literally. So we're doing 3 inches on the top as well. So from our 36 inches, we're taking off 3 inches at the bottom, 3 inches at the top. So if we have our 36 inches, we're taking away 6 inches, which gives us 30 inches for the height on the inside. All right, so if we plug that in, we have pi r squared. R is 21, and our height is 30. All right, so if we're going to box that off. If we calculate that, our volume on the inside is going to give us 13,230 pi. All right, so we want to find the volume of the concrete. So that's going to be basically the blue container without the black container on the inside. So we're going to be subtracting the 13,230 pi from the 20,736 pi. So we're going to take our blue number, and we're going to subtract off our black number. All right, so that means that this is 7,506 pi. Let's create a new tab here. So we had 7,506 pi, and this was in inches cubed of concrete, which if we multiply it out, that'll give us 23,580.79 inches cubed for our concrete. And if we were to put that into feet, it would be about 13.65 feet squared for a volume if we wanted it in feet. But any of these would be, that's feet cubed, excuse me. So any of these answers would be correct for our previous problem. Sorry, again, I ran out of room on there. But that would be how much concrete we would need to make this, this container. All right, so that wraps up 12.4. So you should be able to do your homework. If you have any questions, send me an email. Otherwise, we will discuss 12.4 on Zoom together. All right, have a good day, and I will see you next time.